Hello everybody, welcome back to a Godot Code review. This one is called Chess Mania, and it was a submission for Godot Wild Jam 79, and it was submitted by developer iCode Stuff. The developer's itch.io page is linked in the description below, so please check that out. And before we get into what is going on with the code here, we're going to go ahead and give the game a play and see how it feels and looks. Okay, so this game was created in a week, I believe the developer said. So let's take a look at what's going on here. I'm not exactly sure what this is supposed to represent. Again, we're not going to be really commenting about the gameplay so much. We're just going to be looking at the code and the technical aspects of it. But I actually don't know how to get the game started here. I don't know what's going on here. Let's take a look at the remote scene tree. Okay, so this is the main menu. So maybe I'll just open this up. Play button, quit button. Oh, I see. So I guess I just click. Oh, okay. So yeah, that was not super clear, that menu there. Okay, there's one thing that I'm noticing with that countdown text that maybe we'll talk about later. But the idea of this game is you hold down the left mouse button and you charge it up as long as possible. And then when you release, it creates more damage and more bullets. Looks like I actually got stuck on an enemy here. So, okay. So there's obviously one thing that we can fix right there. Okay, so I'm stuck on an enemy. The spawn text was a little bit kind of weird in terms of how it was scaling. That menu, the only thing I would suggest about that menu is just to make the play and quit a little bit clearer. You might as well just write out play and quit. What I like to do for game jam games is I like to actually forego a main menu in a lot of cases, because what I will do is usually I'll just throw the player into the game directly and then have like an in-game, like something you can do to quit or begin. So you could have it where nothing spawned and then it's like shoot here to begin and then it starts the wave, you know? Okay, so this game is called Chess Shooter, but I'm not entirely sure where the chess functionality comes in. So what I might do is I might take a look at the itch.io page and see if there's anything in particular related to chess in terms of how the movement works. Okay, so I found the itch.io page, and again, the developer's itch.io profile is linked in the description below. But it looks like we just got W, A, S, and D for movement, and there is a known issue which player and enemy can sometimes get stuck in each other. So I will say that this game looks pretty good, and it feels pretty good too, but I'm noticing quite a few problems here, and this is not to pick on the developer, but I think that there is actually a lot that we can do right here to make this feel a lot better, and we can fix some of those bugs too. Before we continue with the code review, I want to mention this video's sponsor, Cody. Cody is a platform that makes learning code fun and interactive and accessible. There are coding challenges, quizzes, and real-world projects. And what I really like about Cody is it's gamified the system where you've got streaks and rewards that you can apply that make it feel really nice to continue to succeed in your learning journey. When you register for Cody, you will be asked a couple of questions that will personalize your initial learning journey. And the learning journey is composed of lessons that are all bite-sized, so they're very easy to digest. You focus on one thing at a time. If you do get stuck on one of the challenges, there's an AI tutor that gives you instant feedback so that you'll never get stuck. Cody is perfect for beginners who have not started coding and want an easy way to get into it. It's also great for people that like to learn at their own pace. Check the link in the description below to sign up for Cody for free. It does come with a daily usage limit, but you can get started right now. Again, check out the link in the description below to sign up for Cody, and thanks again to Cody for sponsoring this video. So let's fix the player getting stuck in the enemies first. So before I even look at it, what I am assuming is happening is that the enemies and the player share a collision layer and a collision mask, which means that the player is actually physically colliding with enemies. With top-down shooters, I actually don't think it's necessary oftentimes, unless you have a very specific gameplay purpose for it, for the player to collide with enemies. So let me just verify that my suspicion is correct. I'm going to quick open the scene. I'm assuming there's going to be a scene called player. We've got that here. The player is using inheritance. So I maybe am earning a reputation in this code review series as being somewhat against inheritance in the vast majority of cases, especially for things like entities. So I'm not seeing any composition used, which is fine. You don't have to use composition in your games if you don't want to. But again, something like a hitbox is a very good candidate for making a component out of it, which means that you just basically make it a standalone scene that's generic that can be used anytime you need a hitbox. But let's take a look at the player character body 2D. Okay, so here's maybe one problem. This motion mode is grounded. When you're in a top-down 2D game, you want the motion mode to be floating. Grounded is more for platformer styles where you can be connected to the ground and you get extra functionality like being able to detect what the floor is and snapping the player to the floor. That may be what's happening here. So change that motion mode to floating for your top-down games where you're not doing like platformer gravity kind of jumping around. And then let's take a look at the collision mask here. So it exists on the player layer and it's looking at enemies and environment. So environment makes sense. Let's actually open up the environment. I bet you what the developer has done is put static body 2Ds around the arena to keep the player from leaving, which is totally fine, but I want to verify that that's actually what's happening. So we've got an environment node here at this game node, which is the main scene. So if I open up environment here, we've got a path 2D, a path follow 2D. I'm not sure what that does, but yeah, here's our static body 2Ds. So these are, so here's our collision shapes here. So that's a perfectly valid way if you have just a very simple arena and you want the player not to be able to leave it, just throw 4 rectangular static body 2Ds on it, very easy. So that's our environment, and these are on the environment collision layer here. These, I don't believe these need to be on a mask. The only reason these would need to be on a mask is if you're listening for collisions, but you don't need it. So this can just be removed. All of these static body 2Ds here, they don't need a mask. They just need to exist on a layer. They're just gonna passively exist on a layer and do nothing else. So in Godot 4, what a layer is it's the collision layer that you exist on. And a mask is the collision layers that you look for collisions for. So mask is like the active part. It's what you're seeking to collide with. And layer is what layer you exist in. In the case of these static body 2Ds, they're not actively looking to listen for collisions and respond to collisions. So they don't need a mask. Now, on the flip side, if we go back to the player here, oh, hello, cat. If we go back to the player here, we do need the player to look for the environment layer in its mask so that it can respond to those collisions. If you put the player in layer 4 and get rid of this mask, it's not going to collide with the terrain. But then we have this mask where it's looking for the enemy. Now, I don't know exactly how this is being used. It may be the case in here that this is how we're determining when the player dies. So what happens when the enemy collides, I believe, is that the player will die. So let's take a look. So there's a player damage signal somewhere. Player damage.emit on hitbox body entered. Yeah, so we're using the hitbox here to detect damage. So I'm fairly certain that what we can do on the player here is let's just uncheck the enemy mask here. And then let's do the same for the enemy. So we've got the enemy here. Let's go ahead and inside of the enemy, let's also make this motion mode floating on the character body 2D there. And then in collision, we don't need to look for the player at all. Let's run the game now and see how that feels. So I'm gonna play. And so now if I move around, yeah, so I'm still taking damage as you can see, but I'm no longer colliding with those enemies. So there's no reason to make the character bodies physically collide with each other. As long as you have those hitboxes in place where you can detect the player being damaged, then it's totally fine. Now I'm noticing a little bit of weirdness with the player movement. It's hard to tell in the video, but it's not exactly input lag. It's like the inputs are sticky. The inputs are lasting longer than they should. So I'm going to take a look at what's going on in the player here. So I'm in the player script here and I reset my layout because I'm not seeing the script window here. Toggle scripts panel. Okay, my scripts panel was missing for some reason. That's very interesting. Okay, so I got my scripts panel back. Anyway, so let's take a look at what's going on in the player here. So we've got direction, vector 2, input, get axis, move left, move right. We can actually change this. This movement direction here in the physics process for determining how the player moves actually can be simplified to this. Var direction is equal to input.get vector, and then we can do move left, move right, move up, and then move down. So this input.getVector does basically what that code was doing on this line here. So we can get rid of that. Now let's take a look at the movement. We've got movement direction. Oh, I see. So direction in the physics process is being retrieved from the input, and then it is being passed into the movement here. Now we've got this if game started. I suppose that's okay. So we're checking if the game is started before we do any of the movement here. If not is charging velocity.x. These look exactly the same. This looks like a redundant statement here. So let's just get rid of those. Unindent that. If movement direction.x, this if check is not necessary because if this is 0 anyway, then you're just going to get an x velocity that gets zeroed out here. So you actually don't even need that. So we'll get rid of that. And then we have if movement direction.length is greater than 0, then we are doing movement direction normalized. So here's the thing with this change that I made here, this input.getVector automatically returns a vector2 that's normalized. So we no longer need that normalization call there. And then we're playing the run animation and setting the walk animation speed. That's fine. Okay, else velocity x equals move towards velocity x 0 movement speed. Okay, there's something very wonky going on here. I'm trying to determine if there's a specific type of movement behavior the developer was going for. Yeah, so this movement code, it looks a little bit weird. I'm not exactly sure what's going on. I hope that the developer is not trying to achieve some kind of particular movement because I'm about to completely delete this and redo it. As far as I can tell, I think that this is just trying to move the player normally and it's not working. So this move towards stuff, this would be useful, I guess, if you wanted to do some kind of like acceleration, I guess, because it's built into this method that it will clamp the value, but I don't think we need this. So velocity.x equals movement direction.x times movement speed. Let's just get rid of this. So I'm going to remove all of this here, and I'm going to change this to velocity is equal to movement direction times movement speed. This is already normalized, so that's fine. And we're just going to multiply out by the movement speed. And then if movement direction.length is greater than 0, this is okay to play a run animation. It's a perfectly fine way of determining if there's some movement input. But then here, we just need to make this an else. We don't need this if statement. That should be it. Now, I don't know why the speed scale is here. I'm going to assume that's okay, and I'm going to leave that. Let me play the game and make sure I didn't break anything. Yeah, this movement is feeling much tighter already. It's very simple. Now, what you could do as well is add some acceleration to this movement. I'm going to go ahead and do that actually real quick so I can show you what to do. One mistake that people always make is they use lerp for something like an acceleration, which is great. That's not the mistake. The mistake is lerp is not frame rate independent. If you have a game running at 30 FPS and you have a game running at 120 FPS, the accelerations are going to be different actually on either machine because lerp is not frame rate independent. And this makes sense, right? Because lerp is moving a percentage of the way from a start point to an end point by a percentage. So if I move 10% of the way to a target location every frame, then you can easily see how when I'm running at 30 FPS, I'm going to arrive at the target slower than if I'm running at 120 FPS, right? So if I do 10% of the way to the goal 120 times per second, and I do 10% of the way to the goal 30 times per second, well, the one that's doing more frames in 1 second is going to get there first, right? But people think that if they just pass in delta to a lerp function, that that's somehow going to make it frame rate independent. That is not the case. The way that you can make your lerps frame rate independent is the following, and I'll show you this. So instead of velocity, we'll do this. We'll say var target velocity is equal to this movement direction times movement speed here. And then what I'll do is I'll say velocity is equal to velocity dot lerp. And we want to go to the target velocity. And then this is a very fancy mathematical formula. I don't exactly know how it works. Don't ask me how it works. But this is just how you get the frame rate to be independent. You can look this up online. I'm not just making this up. If you Google frame rate independent lerp, you'll get all kinds of game dev blogs and articles on why the math works the way that it does. So definitely seek that out if you're interested. But I'm going to do 1.0 minus exp, which is the exponential function. And then we do some kind of negative smoothing value. In this case, I'll do negative 20. And then you can pass in your get process delta time here. So you do need to multiply by delta in this version of the formula, but this is going to make your lerp now, this lerp, is now going to be frame rate independent. So if you're running at 30 FPS or you're running at 120 FPS, you're going to arrive at the target location in the same amount of time. So now I'm going to just see how that looks, see how that feels. So you can see, I don't know if you can tell that well on the screen, but there's a little bit of slowdown and sliding. It's actually a little bit too sluggish for my liking, but the nice thing is that you can just bump up this smoothing value to make it a little bit more responsive. Yeah. So you may say, like, what's the point of making the smoothing super responsive? Well, you'd be surprised. Even something as simple as having like a couple of frames where you accelerate when you start moving and a couple of frames where you decelerate when you stop moving, that can make the difference between your game feeling very jarring and feeling very smooth. It's amazing how subtle that effect is, but it really does make a difference in the game feel quite a bit. And just because I mentioned it at the beginning of the video, I want to look at that countdown timer because the numbers are not centered, and this is a very common issue as well. So this actually looks okay in the editor in terms of it being centered properly. The problem though is in game it looks wrong. See how it's dropping very weirdly? Okay, I figured it out. The reason why this isn't looking good is because the initial configuration of this game time has a new line in it, which is increasing the size of this game time. But then when it's being assigned in the script here, that new line is being stripped, but the size of the label is being retained. So that'll get you. This happens all the time, actually, to me. When you're animating control nodes, you really want to make sure that their size data is not changing, because that just is going to basically ruin your animations, or it's going to make your animations much harder to manage. And that's exactly what's happening here. What I'm going to do instead of this game time, first of all, we're going to get rid of that new line, and that should automatically fix it just right then and there. But what you can do instead is if I reset the size here, we're still maybe dealing with an issue where the size could change, especially if you had like a second number or whatever. So what you can do is I usually just do a custom minimum size that's sufficiently large enough, like in this case, 128 by 128. And just make it a fixed size of 128 by 128. And then that means that if I add more text, I've got a little bit more breathing room where the layout and the positioning of the control node is not changing, right? So I will do 128 by 128 or something sufficiently large, and then you can recenter this with the anchor center there. And now that I've done that, I bet you that this is going to look fine now. It's going to look less wonky. Look at that. So the numbers are nice and centered now. Now it looks actually a little bit off center still, but you know, it's better than it was. I think I got the point across. So that was sort of the stuff I immediately noticed. Let's take a closer look at the enemies. Now, I mentioned this in the previous episode where there's no Y sort, and I think Y sorting would benefit this game quite a bit. Again, let's just take a look at the Y sorting here. So the Y sort is a problem because the player is always going to render behind the enemies, it looks like. But when the enemies overlap each other, you can really see it right there, yeah. So that just doesn't make sense. It just doesn't look good. Y sorting is something that really simple for top-down games that you can do that just makes your game immediately look better. Here, we may end up running into some node issues here. We've got an enemies node, which I'm sure is where the enemies are being added. Oh, it looks like the enemies are just being added as children to this game root. Let me just make sure that that's the case. So now if I pause, go to remote, game, yeah. So this enemy's root is not even being used. It looks like the player may not be referenced at all. So we may be able to fix this relatively easily. So this is the game root here. The game root being a type of plain node is perfectly fine. But let's delete this enemies actually. And what I like to do is I usually add a node 2D and I call it Y sort or Y sort root, like so. That's probably going to need to go on top of the environment. This Y sort root, I'm going to move the player underneath that Y sort root. Camera 2D, I like to put that near the top because the ordering of the camera 2D doesn't really matter. So the way I typically organize my scene trees is that I put the things where the ordering doesn't matter, like in the case of nodes or animation players, up at the top of the scene tree, so that basically nothing that has any influence on the rendering order is just all grouped together at the top. And then all of my node 2Ds follow. And then the node 2Ds have to have a very precise order for the purpose of rendering or drawing correctly. So we've got this Y-sort root here. Let's get a reference to that Y-sort root. And this is a quick tip that I think is pretty common knowledge now, but if you don't know, you can drag a node over and hold control into your editor, and that creates an onReady variable for you. So we've got the Y-sort root. Instead of adding the child directly here, we're going to do a Y-sort root.add child, new mob. Now we do need to look at the enemy and make sure that the positioning is correct. So the positioning here is all off. Again, if you watch my previous code review video, the Y-sort will work based on the origin here. And so in order for the Y-sort to work in a top-down game, you want the origin to be around the feet, or you want the feet to be around the origin rather. So we got a visuals node here, manipulate this offset here. So I'm going to uncheck that and center this like so. There's that. And then of course, now that we've reoriented the player, we need to change the character body 2D collision shape, which is where? Here it is. So we're going to take this collision shape and we're just going to move it up. I know you can't see it, so let me see. So we're just going to move it up like that. What I typically do is I just do a circle with the bottom of the circle touching the X line here, and that's aligned with the feet. Actually, what scene is this inheriting? Base character. Yeah, I think honestly, for a jam game like this, it was a mistake to make the player and the enemy extend from the same base scene. Again, I understand the impulse, and it's good thinking in a way that, you know, you're going to have very similar scene structure, so why not reuse it? But especially in a jam situation, I think that this has the opportunity to tie you in a bunch of knots rather than actually be useful. So for a game jam, I almost always just build my characters from the ground up, because in a game jam, you typically only have like 2 or 3 entities, and whatever functionality they may share in common actually ends up binding you or like limiting your capabilities if you try to make them use the same inherited scene. It's just, again, I just don't find inherited scenes that useful, especially for characters. I vastly prefer a composition design where you just build your characters from the ground up with composition. We're just going to leave that alone for now. I have not yet enabled Y-sort. So if I go to game here, and I'm going to move this out because I think my face is in the way. So hopefully you can see this. But if I select Y-sort root and go to ordering, we've got Y-sort enabled, turn that on. That should be all that we need to do here. Now let's go ahead and run the game and see how that looks. Oh, and I just got a crash probably because I moved something around. Ooh, okay. Yeah, so we've got a really bad thing going on here. It's good that this happened. So when I moved the player under the Y-sort root, I did not see the player being used in the game script at all. So I assumed, hey, it must be the case that I can just move the player wherever I want. Problem being now, though, that it turns out in the enemies are actually getting a direct reference to the player based on an absolute path. To the developer and also to everyone watching this, absolutely do not do this. Do not assume ever that you know the position of a node based on its absolute path. Never do that. There should be very, very few instances, generally speaking, where you use an absolute path to a node for the reason you just saw. I thought I could move the player around in my scene, but then I broke something that wasn't immediately obvious to me. Now, in this case, the game immediately crashed, so it was made obvious to me. But the problem is you should not rely on an absolute path. You should not assume that you know where a node is in the scene tree, because as you start moving things around and reordering your scenes, you're going to run into exactly these kinds of problems. So how do we fix this? Well, the way that I typically have my enemies get the player is I go to my player scene here and I go into the groups, which is in node here, and then go to groups. This is already in a player group. So we already have it as part of a group. I wouldn't even store a reference to the player. So here's the other piece of advice I would give you is that if you have a node that can be transient, which means that it may not exist at some point in the scene tree, you should always treat it as if it might not exist. So in the case of the player, This may not be the case in this game, but it's very common for the player to die and to like be destroyed or something. And if all of your enemies are storing a long-lived reference to the player, they're going to start crashing as soon as the player gets removed from the tree. Like even just not freeing, you could just remove the player from the tree because you want to do a transition or something. And that's going to break anything that has a direct reference to the player, especially if you're doing tree operations on that player. It may not break the reference if you're just removing the player from the tree, but if you're assuming that the player's in the tree, it's kind of the same issue. So I would just get rid of that player reference there. And then in here, what I would do is in the ready method, So, I see. We want to connect to the damage signal. Why do we want to connect to the damage player signal? I should probably try to understand why all of the enemies are trying to connect or are connecting to this player damaged signal. I'll use this opportunity to show you another thing that you can do, which is to have sort of like a global events or a game events auto load, because this is how you could listen for things that you need to be aware of. Let me do that first, and then I'll circle back to this change that I was making with the player group here, because I think, we're definitely going to want to get the player here. So I'm going to create a new auto load. This is just not super important organizationally for demonstration purposes. Obviously, if you're making a real game, you should put this in an appropriate spot. But this is going to be inside of game events, a script here. We've got extends node. And then what I would do is I would do this. I would have a signal player damaged. And then I would do a func in here, emit player damaged. And then I would just do player damaged dot emit like so. Let's go ahead and add that as an auto load here. So this may be a little known fact too. You can either add a scene or a script that extends node as an auto load. So I just created a script. I didn't create a corresponding scene, and I just click add there. So close that. So now we've got this. So if I go to my player script now, what I would do in here is wherever player damaged is emitted. So it's emitted in here. Then this is where I would do game events dot emit player damaged like so. So now we've got a global event that's notifying anything that wants to listen that the player has been damaged. What you could do optionally too is you could pass in a reference to the player as an argument so that you know which player got damaged, and you can pass that through in the signal emission from the game events. We don't need to do that in this case, but that's something that you could do. Let's go back to the enemy now, and we'll replace this connection here with game events .player damage.connect, damage player. Another minor stylistic thing here is I like to always name my signal handlers with on as a prefix. So I would do on player damaged. So this is like the past tense sort of verbiage here. Again, that's a stylistic thing, but I'm just going to move this down with the rest of these. And then in here, this would be on player damaged. So that should be functionally equivalent. And now we don't need to store a reference to the player so that we connect to that. And now in this direction here, what I'm going to do is this is not really a good place for the function, but I'm going to do func get player. And then I'm going to do return get tree dot get first node and group in that player group there. And then I'm going to do var player is equal to get player. If player is equal to null, then we can just return out of that. Or what I would do in here actually is I would just set the velocity to 0. Again, you could add some acceleration here, but let's do else. And then you can leave these alone. So you still want the enemies to do their movement if the player doesn't exist. You just want to change what the target velocity is in that case. And then down here, we'll say var player is equal to get player if player is equal to null. What we could do in here is we could probably just return. Now, I don't know where dash is actually called. It looks like it's called here. If can dash and not is dash on cooldown and not is dashing. So this is dash on cooldown is a little bit suspect. And the reason it's a little bit suspect is because you already have dash cooldown data, and that's in the form of if the timer is running, right? So if I go to my enemy here, we have the dash last time and dash delay. One of these is going to contain the data about whether the dash is on cooldown or not. So let me look where dash last time is, dash last timer. So let's figure out where this is used. Okay, so these timers are very confusing. I think what the developer wants to do is just make sure that the dashes don't happen quicker than a set interval. And the developer did mention that this was some of the most messy code here. Okay, so I think fundamentally what's happening is basically this developer is just trying to manage the state of the enemy's attacks by coordinating a bunch of timers and flags. So really what this is begging for is a state machine. So I'm actually going to use my callable state machine implementation again, which I did in the first episode of this code review series. The reason I like to use that callable state machine is not because I think it's like the best thing ever, but because it's readily available to me, and also it handles enter and leave states, which is going to be important for this because we have animations that happen when you enter a state and when you leave a state and all that stuff. So what I'm going to do is I'm going to try to recreate the enemy behavior using the callable state machine. So the first thing that I'm going to do is I'm going to create a callable state machine script at the root of the project. So we'll just do callable state machine. Again, you would want to put this somewhere more appropriate, but I've copy and pasted my callable state machine into there. Go back to the enemy. All right, so I've rewritten a lot of the enemy logic using the state machines. I didn't rewrite all of it, I copy and pasted stuff, but I did make some changes that probably have a gameplay impact, but that's fine. I'm not trying to maintain parity. I'm just trying to show you how you can convert this to a state machine. So the first thing that I'm going to note is that this developer was using timers quite a bit, but a lot of the timers were not set to use one shot when they probably should have been. One shot makes it so that the timer counts down once and then doesn't start again. So there were a couple of places where it looked like you were trying to handle the fact that the timer kept on running. It's much easier in a lot of cases if you're trying to use timers for gameplay reasons to just turn one shot on so that you have control over whether the timer is started or running and it's not just always running. And you'll see why that's important in just a second here. But first, so my callable state machine, the way that it works is you have this add states function on the state machine object, which is instantiated up here. And the first argument is a callable, which is just a reference to a function, basically. That is the normal state, and then you have an enter state function, which will be called when the state is first entered, and it will only be called once when the state is entered. And then you have the third argument, which is the leave state. So that would be called when the state is being left, but before the next state's enter function is called. And then the normal state is the state that is expected to tick every frame. So in this case, in my physics process, you can see that I've got state machine.update and then move and slide. So this update is calling one of these normal methods every physics frame, and then I'm also applying the movement all the time. So the move and slide is being applied outside of the states because the states are only responsible for changing the velocity, whereas the velocity should always be handled. If you don't want your entity to move during a state, you should set the velocity to 0. But this just makes it much nicer. I don't have to call move and slide everywhere. If I scroll down, so the initial state is the state spawn. That triggers on enter the spawned animation. And then once that animation is finished, it will change into the normal state. The normal state just looks for the player. So in here, we're getting the player from that function that I wrote. And then if the player doesn't exist, we'll just set the velocity to 0. The player should always exist in this game, but I just wanted to be complete here. Otherwise, we're going to play the run animation. And then I also removed the use of this player dash detector. This was basically an area 2D that was detecting when the enemies were inside of a radius. You can do that if you want, but for state machines particularly, it's much easier to just check if the enemy is within the distance that you're checking here, because then it allows you to do other things like this, which is I can add another conditional on here. Previously, what I'd have to do is detect if the player has entered the body, but then also like keep track of if the player is still there, right? Because if the player enters the body, but I don't yet want to trigger something like the dash attack because, for instance, it's on cooldown, well, now I've missed that event. That event did not coincide with a situation where the dash could begin. And now I need to store that so that when that dash cooldown timer is done, I can then detect, okay, is the player still within the area? So in my opinion, it's much easier just to redo the check every frame. So this check is saying, if the player is within 50 pixels of the enemy's position, and this dash cooldown timer is stopped. This says dash last timer. I repurposed it to be a cooldown timer. And this timer is stopped, then we can change into the wind up state. And then you can also see here the velocity is being applied here. So this is what I was talking about with the timers though, is that I'm manually controlling the timer by calling start and having it one-shot mode. And the reason is because when it's in one-shot mode, I can easily check if it's stopped, which means that its cooldown has elapsed, it's no longer running, and that means that I can do whatever logic I want now. So that's a very nice way of doing that. In the dash wind-up state, we're just playing the attack indicator animation. We'll set the velocity to 0 and then start the dash timer. And then this normal state, so the state that gets ticked every frame, we'll just check if this dash timer that was started up here is stopped, again, using that timer trick that I talked about. And then that will set the state into the state dash. When we enter the state dash, again, we're going to target the player. If the player doesn't exist, we'll just switch back to the normal state. Again, the player will exist. So this is kind of redundant here, or not necessary rather. Otherwise, we're setting the direction to the player, the direction facing the player, and then we're setting the velocity in one go right here to 500 magnitude. So a 500 pixels per second velocity times that direction. And then in the state dash, which again is ticked every frame, it's doing a lerp. So it's going to 0 at this rate. Again, this is the frame rate independent lerp. And then the velocity.length, if it's less than 25, which is just an arbitrary number that basically says, hey, we're moving slow enough now, then we're changing back into the normal state. And then when the state dash is left, when we exit the state dash, then this dash last timer, which is the dash cooldown timer, is started, which is 1 second. So this basically just ensures that the dash cannot happen more than once per second. So now if we go into the game and we look at this and I trigger a dash, we can see that the enemies are now dashing. They're basically going through those states. They cannot dash more than once per second. And you can see, though, I've got a situation where they're leaving the arena there. So let's just fix that really quick. The enemies, it looks like, are not colliding with the terrain at all, the environment. So I'll just turn on the environment mask there. I don't know if I turned that off or that wasn't there, but they definitely need to have their environment mask set on the enemy character body 2D so that they don't go off the screen. So yeah, that's basically it. That is how the enemy logic looks with that callable state machine, and it's still very functional. And I just think it's a lot easier to reason about, because the thing that's nice about state machines is, number one, you don't need to manage a bunch of Boolean flags all over the place to decide how the enemy should behave. Each state is very sort of isolated to itself, meaning that when we're in the normal state, this is all the code that's ever going to run during the normal state. There's no side effects. I don't have to worry about some kind of flag being set that all of a sudden is going to change the conditionality about how the enemy is behaving. It's just whatever code is in here is what gets run. And the state machine's state does not change until I tell it to, like here when I tell it to change the state. So thank you again to iCode Stuff. Please check out the developer's itch.io page linked in the description below. I would very much appreciate that, and I'm sure the developer would as well. This was a great project to look at. I think that, first of all, congratulations on submitting a game to a game jam. Not many people can do that, so you should be proud of that. And also, I want to thank you for submitting this project, because it ended up being a very good, valuable learning resource for everyone, and I hope for you as well. So thanks for watching, everyone. That's going to be it for this code review. Leave a comment. What did you like most about this video? Was there anything in particular that stuck out to you as something that was a particularly useful piece of information? And if you want to submit your Godot project for review, check out the link in the description below. There's a Google form link where you can do that. I'm accepting projects in any stage of development, whether you're talking about game jam games or template projects or a project that you're about to release on Steam. I'm open to any and all Godot projects, so submit them using the link to the form in the description below. Thank you everyone for watching, and I will see you in the next one. Thanks for watching this video. If you want to support my work, you can purchase one of my courses, you can purchase my game Gunforged on Steam, and you can sign up for my email list at firebelly.com. All the ways that you can support me are linked in the description below.